So welcome back to Organic Lab. This is the final lab of the semester, and today we're going to be setting up the reaction of methylcyclohexane with sulfuryl chloride to do a free radical chlorination. So I've already gone and gotten a couple of clamps. And we're going to have one clamp that we're using to connect the main reaction assembly, and then we'll have another clamp that we need, and that's going to be connected to our beaker that has sodium hydroxide in it that prevents the HCl gas that's liberated during the reaction from getting out into the atmosphere. And that's going to be one of these things in a 50 milliliter beaker. And we're going to clamp this so that it's just touching the beaker. Actually, I don't want that in there yet because I still need to attach some hoses to these things. So the first thing I need to do is fetch the glassware that's been sitting in the oven for a couple of days. An hour would have been good enough, but I sat it in there a couple of days ago when I was last in. Because the sulfuryl chloride reacts very readily with moisture in the air, and there's a lot of moisture in the air right now in Ohio, to form HCl and sulfuric acid. So I'm going to stick that in there. I've got in there a 5 milliliter conical vial and a Spinvane, and then I've also got the thermometer adapter and the condenser. Basically the entire portion of the reaction setup that's going to come into contact with the sulfuryl chloride. So that's going to cool in the desiccator. And while that's cooling in the desiccator, I'm going to set up my gas trap. So I'll need a piece of red rubber tubing. Make sure that it's not too crunchy. It's a little crunchy. It's obviously been used for this purpose before, but it's not falling apart, so it's probably good enough. And I want to attach this to one end. It's not a very tight fit, so I'll need to use a hose clamp to make sure that stays attached. And I'm not sure if this is the right size hose clamp. I'll have to get a better one. Yep, that does look like that's the right size. You'll see there's a little lip there. I want to put that clamp approximately where that lip is, so that it can fit tightly. And the lip's about there. I want to stick for some reason. Maybe that isn't big enough. Try one of these white ones. See if that's a little bit bigger. And if not, I'll go get the ultra size ones. Yeah, that one's fitting a little bit better. Maybe. There we go. 3 clicks. So that's on there tight. That's not going to come off. And now I can clamp that. And adjust it. So we're going to have a beaker here into which we're going to add 5 milliliters of 10% sodium hydroxide. The actual volume is not absolutely critical. I've got about 7. There we go, that's 5. And this has nothing to do, it's not part of the reaction. Its sole purpose is to absorb HCl. clamp that so that it's just kind of touching but not fully submerged. And of course it moves as you tighten it. Alright, so there we go. That's our gas trap. Make sure that the HCl doesn't come out. Granted, we're working in a hood, so it would just go up in there, but HCl decomposes metal things pretty readily. I'm going to use a pipette to measure out the methylcyclohexane. Make sure I have a nice dry graduated cylinder. And we need 3.2 milliliters of methylcyclohexane, so these go to 0.2 millimeters, or 0.2 milliliters. This is going to be the right thing for measuring that out. And I'm going to use a pipette rather than trying to pour it, because 3.2 milliliters is not very much, and I'll be able to get a more accurate reading this way. This is going to go into that conical vial once it's cooled. Graduations are 0.1. So that is 3.2 milliliters. Pretty close to exactly. Don't need this pipette anymore, so into the glass waste. The sulfuryl chloride is going to be measured out with a syringe, so I'm going to open up a nice new needle. These are 22 gauge needles, 1 inch long, and I've got a nice clean syringe. So I'm going to be measuring out 0.4 milliliters using my 1 milliliter syringe. And then the last thing I need for this reaction is I need some benzoyl peroxide. I need 30 milligrams of benzoyl peroxide, and the benzoyl peroxide is in the refrigerator. That's calcium hypochlorite. Here's the benzoyl peroxide. Looks like that is in an open bottle. There we go. Dibenzoyl peroxide, 75% remainder water. That is not the right benzoyl peroxide. Don't really want the water in it. Yeah, guess that's what we have. That's what we're going to use. 30 milligrams, right? There won't be very much water in there. That will react with a little bit of our sulfuryl chloride, though. So I need a micro spatula. Smallest spatula. I always crease the weighing paper because that'll make it easier to transfer the benzoyl peroxide. So we'll tear that piece of paper. And then 0.030 grams of the benzoyl peroxide, which is really not very much. Just a catalyst. You can see it's a little wet, kind of old material here. Yeah, hopefully it's still going to work. Stuff really does not want to come off my spatula. So it's actually 0.033 or 33 milligrams of benzoyl peroxide. That will be adequate. Going to give that a little sweep off. Alright, so we have our reagents ready. Hopefully that stuff is now cool enough to work with. There's our benzoyl peroxide. It's important to cool it in a desiccator because otherwise it absorbs moisture from the air, and there's a lot of moisture in the air, so I'm going to be careful. So we've put our Spinvane in there so the pointy end is down into the bottom of the vial, and we're going to be attaching these two pieces to the top. Using the nuts and the O-rings. Right, this is standard taper 1410 glass, right? Standard taper 1410. And these nuts are designed to prevent the pieces from coming apart. I'm going to get a third one out because we'll need it when we have our Hickman still for the purification part. So the way this works is you stick the nut over the ground glass joint and then roll a O-ring so it's just above the joint. That prevents this from coming off. So I will be able to attach that, and when I screw that tight, now that won't come off the end, and I can attach the clamp to just the condenser part and not have to worry about this falling off. And then I'm going to attach my thermometer adapter at the top, also using one of these O-rings, so that'll work out nicely. So we'll clamp that like that. I usually pinch them and then just kind of spin it so it's most of the way shut. And we'll put this other set aside for later when we need the Hickman still. Oops, wrong door. So I need two pieces of tubing for my condenser. And for that condenser we want to use the amber tubing. Take off our aerator. And again, these slide on much better if they're already a little wet. So I'm going to put a little water in a beaker. It'll be much easier to get those onto the various things they have to get on if they're wet when we slide them on. Slide that on all the way. I don't want it to come off in the middle of the reaction. And then, as always, I'm going to put a weight on the end so it can't fall out. And I like to nut around the back. Get my stir plate out. And to heat the vial, I'm going to use one of these aluminum blocks. So we'll run this through and plug it in. Make sure it's working. Yep, we got our light. And the aluminum block sits on top. And then the vial will go down into the aluminum block. And we want that as close to centered on the hot plate as possible, which is why I have this ring stand turned around. And these auxiliary blocks will make sure that the entire vial gets heated. So I got that system set up. There's my methylcyclohexane that I measured out. I need to get this piece of tubing over the top of the thermometer adapter so that any vapor that's generated in here comes up through the thermometer adapter and bubbles through the potassium or hydroxide solution, sodium hydroxide solution. So sometimes it's a little hard to get that on there because it's a pretty large opening, but there we go. So we got that attached. Run that over so it doesn't actually come into contact with anything hot. And since I don't want that to kink, I'm going to get an iron ring to attach